Good day, guys. In today's conversation, we're going to discuss two proof-oriented triangle theorems. Not one, but two. Two proof-oriented triangle theorems for the price of one. Okay, Theorem 53 in the book, as it's known, if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So if angle C is congruent to angle K and angle B is congruent to angle J, then angle A is congruent to angle H. And we can pretty much derive this from the fact that we can take angle measurements. Let's assume that for discussion here that angle C is 30, well, angle K would have to be 30. And if angle B is 100, angle J is 100. Well, because of what we've already learned by triangle angle sum theorem, where the sum of the measures of the angles of a triangle equals 180, we would then be able to derive that, hey, this angle here has got to be 50, and this angle here has got to be 50, which means then that these two angles are congruent. And
I'm gonna blow you into a million wabbit cut.
yeah, they call this the third angle theorem. The book calls this the no. Let's try a different color so we can actually see that. The no choice. Well, no choice theorem. Okay, theorem 54 says if there's exists a correspondence between the vertices of two triangles such that two angles on the non-included side of one triangle are congruent to the corresponding parts of the other triangle, then the triangles are congruent. So if angle A is congruent to angle D, and angle B is congruent to angle E, and side segment BC is congruent to segments EF, then triangle ABC is congruent to triangle DEF. This is nothing more than the love child between third angle theorem or no choice theorem and angle side angle, because by no choice theorem we would say that these two angles are congruent, and we can say by angle side angle the two triangles are congruent. Well, now we can basically just say, and we can decide, or whatever we can derive, that if two angles and a side of a triangle are congruent to two angles on a side of another triangle, the two triangles are congruent. Now we just have to decide which method we're using, angle side angle or
Be very, very quiet. I'm hunting rabbits.
angle side congruence. You might have been able to figure out we were going that way by this here. Angle side. Again, do not put angle side, because then I will circle it and point to your name. All right, so here we have two triangles. We want to prove that this third angle is congruent. Well, we have no side information, nothing. So we're going to use our given. Angle A is congruent to angle D. That's given. So the next thing we can say is angle ABE is congruent to angle DBC because vertical angles are congruent. Now we're going to say that angle E is congruent to angle C, and you can say third angle theorem or no choice theorem. Either way is fine. Next, given angle N is congruent to angle angle N is congruent to angle R, angle NTR is congruent to angle P, segment TO is perpendicular to segment NP, segment TS is perpendicular to segment PR, and segment TO is congruent to segment TS. We want to prove that NPRT is a rhombus. So that's quite a bit of info there. So let's go ahead and do some markings here. So angle N is congruent to angle R, and this whole angle is congruent to this whole angle. And we've got TO, perpendicular to NP, and TS. Let's put this, hold on. I want to put this inside. And we've got segment TO is congruent to segment TS. So, how can we go about proving that those two triangles are now congruent? And then, thus, proving NPRT is a rhombus. So the first thing I'm going to say is, I'm just going to list all of this given. Angle N is congruent to angle R. Angle NTR is congruent to angle P. Segment TO is perpendicular to segment NP. Segment TS is perpendicular to segment PR. Segment TO is congruent to segment TS. All that's given. Well, I'm going to take these first two here, this and this, and that's going to lead me to, I'm going to put this in the same color, that NTRP is a parallelogram, right? So I can prove a quadrilateral is a rhombus. I've got to first prove it's a parallelogram. So now we're going to use, so a quadrilateral with opposite angles congruent implies parallelogram. Okay, next, let's take a look at this information here and this one here. So we're going to state that angle TON and angle TSR are right angles. That's by the definition of perpendicularity. Now, we're going to say that angle TON is congruent to angle TSR because all right angles are congruent. Now we're going to take steps 2 and combine it with 3 and 4, and we're going to jump right back into angle. No, wait a minute, stop. I don't have to do that. I'm going to use this information here, and I'm going to say now that triangle TSR is congruent to triangle TON, angle, side. So next, I'm going to say that segment TN is congruent to segment TR by CPCTC, and then NPRT is a rhombus. Why? So, consecutive sides of parallelogram congruent implies rhombus. So, there's our proof. You'll have your work to do here shortly. So enjoy this little vignette, and we'll visit soon. Stay healthy.
In a winter wet barn on the farm down in Indiana, for the sycamore trees where the wabash breezes play, was a small red pining for a yellow moon that shines. On a little red barn on a farm down in Indiana way. I said Indiana way.
That's all, folks.